Our next strike-based Greek is theta, and theta is time decay. And what theta tells us is how much our options price will decay or lose in one day. Now, so that you know, theta is given in dollar amounts. So when you see a theta number, think cents. Options are known as a wasting asset. The reason people call them a wasting asset is because they have an expiration date. There's a point in time where that option ceases to exist. During that time, from the moment the option is actually on the board till the time it comes off the board and expires, we see that the option's value decreases when we look simply at the passing of time, keeping all other things equal. The part of an option's value that decreases is extrinsic value. And that extrinsic value decays at a non-linear rate. What does that mean? It means, say we have an option that's worth $1 of extrinsic value, and we have 20 days until expiration. That option is not going to decrease in value 5 cents a day for all 20 days. If it did, then options decay or time decay would be a straight line. But it's not. It's a curve. Options decrease in terms of loss of time value, theta, in a nonlinear rate. It's not an equal amount day in and day out. Now, we know that options have two separate values. One is intrinsic, and we know that only in-the-money options have intrinsic value. It's the amount that the option is in the money. And we've talked about that calculation when we were talking about the beginner class. When we were in beginner class, we knew that when an option is in the money, and we described in-the-money calls as any call whose strike price is less than the current stock price, and a put as an in-the-money put being a put with a strike whose strike price is higher than the current stock price. And we said only in-the-money options have intrinsic value. That intrinsic value, if you want to think about it, is kind of like immediate satisfaction value. If I own the 25 calls with the stock trading at 30, I would say, hey, I have the right to buy the stock at 25 while it's currently trading at 30. That means I could exercise my right, buy the stock at 25 through my call, and then go into the open market and sell it right away for 30. I would see a $5 value in that. There's real innate value in that. That's intrinsic value. For a put, let's say the stock was trading at $50, and I own the 55 put. The 55 put gives me the right to sell the stock at 55. If I use my right to sell the stock at 55 through the use of my put, then I could sell it at 55, go into the open market, buy it back for 50. Again, there's real innate value there, a $5 value. That's intrinsic value, and only in-the-money options have intrinsic value. Any amount that an option trades over intrinsic value is extrinsic value. That is the amount that's susceptible to time decay, or theta. As time goes by, that extrinsic value in the option decreases. It decreases in a nonlinear fashion. So it's only the extrinsic value that gets hit by theta. That means we know that if we have an option that we own that has heavy extrinsic value, it's going to have heavy theta. It's going to decay more rapidly than another option would. That's really good for us if we're short the option, but it could be bad for us when we own it. We need to know what theta is and where theta is the biggest. Now, we talked about time decay, and we said that, look, options, that extrinsic value part of them, doesn't decay equally day in and day out. You can't just say, oh, there's this amount of extrinsic value, there's this amount of days, divide the extrinsic value by the amount of days, and that's my theta. No, it doesn't work like that. Theta really starts hitting an option normally around 60 days out. And as we start getting closer and closer to expiration, theta becomes more and more aggressive. Take a look at the extrinsic value decay chart. This is a chart of theta. As you can see up top, we're looking at months to expiration. Your out-month options don't really decay much month to month. But as we start getting closer to expiration, we start seeing that theta picking up. This slope becomes steeper. That means the option starts decaying at a quicker and quicker rate. Here's a days to expiration chart of theta. Again, as we're getting closer to expiration, theta really starts kicking in. You're going to notice that longer term options don't decay as quickly. However, shorter term options decay at a reasonably rapid rate. That is what we mean by nonlinear. The slope is not consistent throughout the curve. If it was, we'd have a straight line from here to here. But we don't have a straight line. Theta is bundled much more heavily in the front months where there's less time to expiration. Now, what we need to do is we need to look at the theta chart. And you might say, why? Who cares? Well, think about this. If we're going to be buying an option, don't you think we should know where theta is the heaviest? Don't you think you should know where we're going to come across the highest amount of decay, the most rapid decay? On top of that, what if we're premium collectors? In order to be a premium collector, we have to do what? Sell options. When we sell options, we start collecting that decay. Why would we want to sell an option that has no extrinsic value, that has no theta? If we're trying to collect decay, we want to sell an option that's heavy in extrinsic value with a big theta. So understanding where theta is the heaviest and where it's the lightest can give us a good idea of which types of options we'd like to buy and escape decay, and which types of options we want to sell and collect decay. We also know that the passage of time affects a few things. Number one, we know the time affects delta. We talked about this when we talked about delta. Remember trumpification? Here it is, a time effect on delta. So we know that time decay affects delta. It also affects gamma. And it has a relationship with gamma. It not only affects gamma, but it has a relationship. Wherever gamma is the highest, theta is the highest. Wherever gamma is the lowest, theta is the lowest. So we do have a little relationship here. So when we go back and think about gamma and where gamma was big and where gamma was small, gamma was biggest where in any given month? At the money. So is theta. They're related in the fact that they're both risk-based Greeks. Theta is also highest at the money. And we remember that gamma decreased as it moved away from the strike in either direction. So does theta. And gamma decreases as we go out further in month. So does theta. Let's take a look. Now, remember, theta is given in what? Cents. These are dollar numbers. When we see 0.059, that's 5.9 cents. 0.055, 5.5 cents. So these are actual dollar numbers. The actual dollar amount that your option will decay in one day. When we look at June and we look vertically at theta, what do we see? Again, highest at the money. As we move further out of the money, it decreases. As we move further in the money, it decreases. Why? Well, when we move further in the money, we have options that start acting more like stock. And stock doesn't decay. It might go up, it might go down, but it doesn't decay day to day. So if this option here is trading just like the stock, it shouldn't have any decay. Because this option here, this deep in the money, will trade with almost only intrinsic value. If it has no extrinsic value, then it's not going to have decay. Stock only has intrinsic value. There's no extrinsic value in stock. Thus, it doesn't decay. Same with any deep in the money option that is acting just like stock. An option with 100 deltas that is said to be trading at parity. What does parity mean? Parity means that that option is trading with only intrinsic value. Well, if it's trading with only intrinsic value, trading at parity to the stock, then there is no extrinsic value to decay. And thus, the theta would be 0. We see that in the middle here, the at-the-money options, the ones with the most extrinsic value, they have the highest rate of decay because they have more extrinsic value to decay. Go out to the next month. What do we see? Again, we see the highest decay at the money. And as we move in either direction away from the at the money, we find that our theta decreases. And we see the same effect in October and January. When we look vertically in any given month, the highest decay is always in the at-the-money option. Now, when we look horizontally across the different strikes, what do we see? Just like gamma, we see decreasing values. As we go out further in time, we find smaller thetas. This goes to the point or the concept of theta being nonlinear. Out-month options don't decay as much. Front-month options decay a heck of a lot more. Even though the total extrinsic value of these front-month options is less than the total extrinsic value of these out-month options, these are decaying quicker because they're closer to expiration. Time is really ticking on these things. Out here, we've got 6 months. Day goes by, who the heck cares? 6 months. Here, we've got 18 days. A day goes by, that's pretty big, because now we're only down to 17 days. That's why the front-month options decay at a quicker pace than the out-month options. Now, you might wonder how theta would affect you. Let's see how it actually affects a single option. So if we have a position in the June 65 calls with a theta of 0.059, which is 5.9 cents, which is roughly 6 cents. If we have a position in that option, and that option is worth $2, with all things being equal, volatility staying still, the stock staying still, just the passage of 1 day. When we went to bed, the stock was trading at $2. Excuse me, the option was trading at $2. The next morning, when we wake up with a 6-cent decay, we should find that option now worth $1.94. When we talk about theta, we're talking about what happens in the passage of time. It never goes the other way. It always takes away from the price of the option. There's never a moment in time that time goes the opposite way. So what we're looking at is, as days go by, and they only go by in one direction, this option loses value that way. The July 70s, 0.038, 3.8 cents, roughly 4 cents. If they're trading for $1.50 and 1 day goes by, all things being equal, The next day, we'll see this option worth the $1.50 minus the 4 cents, or $1.46. Theta is telling us how much in dollar amounts our option price is going to decrease with the passage of 1 day. That only affects an option's extrinsic value. What about this one, the June 50s? 0 theta. If there's 0 theta, but still time left, it means that this option is trading at 100 deltas. It's got to be, because the only thing that has no extrinsic value is stock. This option, at this moment in time, is just like the stock. It's trading with 0 extrinsic value. It is in the money by about $15.50. I bet you the value of that option is $15.50 at parity with a stock price of $65.50. That's how we need to look at theta. For you sellers out there, why would we ever sell an option out there? Why would we sell the 6-month out option to gain 1.8 cents a day? I have a better idea. I'm going to show you sellers out there, you premium collectors, why you should never sell an out-month option for premium collection. I know that you've heard it from other instructors. Buy the stock and sell some leap. Wrong. And I can prove it mathematically that it's wrong. And we're going to take a look at that. I'm going to flip to this other slide, and you're going to see why it's wrong. Here we are back at this extrinsic value decay chart. And I'm going to show you what I'm talking about. Why you should never sell an out-month option for premium collection. When we look at how the option decays over time, look at the slope here. From an option that's 5 months out, 30 days past, it's only 4 months out. Is there any slope there? I don't see any. That means this option is not decaying. And if I'm a premium collector, I'm supposed to be taking advantage of decay here. And it doesn't look like there's much there, does it? Instead of selling this 5-month option, what true premium collectors do is they sell the front month option 5 months in a row. What happens? I collect in month number 1, while you collect this lack of slope, month number 1, I'm collecting this slope. Second month, you're right about here. Look, from 4 down to 3, what do you have? Next to nothing again. In the second month, I sell the front month option again. Look what I collect. Look at my slope. I've got 2 of these now. You got, let's see, nothing. Month number 3, when the option moves from 3 months out to 2 months out. Oh, yeah, wow, hey, nice job. Congratulations. It's taking you 3 months to collect what? Oh, a little bit. I'm going to sell this one again. The fact of the matter is, if you sell the front month option over and over, month in and month out, for the same amount of time of the month option that you thought you were going to sell, you're going to collect a much greater amount of money. All you need to do is bring up your trading platform, look for yourself, find an option that's got about a month out, and take a look at its total price, the total amount of extrinsic value in that option. Then what I want you to do is go find like a 9-month option and take a look at its total price, its total extrinsic value. And what I want you to do now is think about taking that front month's extrinsic value and timesing it by 9. You're going to have 3 times more total premium collected by selling the front month option for 9 straight months than if you would have sold the 9-month option. That's because extrinsic value is a function of the square root of time. I don't want to blow you away with the math on it. But all you need to do is open up your platform, go to Thinkorswim, open it up. Take a look at what I told you to look at. Look at that front month at the money option, the one with the heavy extrinsic value. And then look out at a 9-month option or an 8-month option, whatever's out there. And take a look at the total extrinsic value there. If we sold that one, we would collect that extrinsic value over the course of 8 months. But if we sold the front month 8 straight times, we're going to collect a gigantically superior amount of premium. It's not even close. If it was close, I wouldn't bother telling you this. But I just seen so many people fail at real, true premium collection because they don't understand this curve here. You want to talk about how something affects your profitability? We're talking about it right now. If you're a premium collector, we're thinking about selling at the money options where the extrinsic value is the heaviest. And we're thinking about selling the front month over and over and over again, month to month to month to month, not selling an out month option. Take a look in your platform, see the numbers, see that I'm right, and the next time you want to do a covered call strategy, don't buy the stock and sell an 8-month option. Buy the stock and sell the front month option 8 straight times. That will get you the type of results that you're looking for from Theta. Our final strike-based Greek is Vega. Vega is very important. V for Vega, V for very important. The reason is that Vega measures the change in an option's price due to a 1-tick movement in volatility. Vega is probably the reason why most of you have had bad experiences with options, because volatility moves independently of stock. A lot of people don't realize that. Many people coming directly from the stock market, they're used to one thing controlling the stock price: supply and demand. The stock moves based upon supply and demand. And that changes the price of your stock. Here in the options market, we not only have the movement of the stock that can change prices in options, but we also have the movement in time and here, volatility. Now, does anybody remember ever thinking that a stock was going to go up and you said to yourself, you know what, I'm not going to buy the stock this time. I'm going to try those option things. I'm going to try those calls. I'm going to buy a call instead of buying the stock. You went out, you bought the call, sure enough, the stock goes up. But your call loses money. And you can't understand it. You're like, I don't understand this. The stock went up. How did my calls go down? Volatility. Volatility went down, and Vega sucked out more value in your option than the delta was able to put in. Many of you are probably scratching your head going, oh man, that happened to me. Geez, is that what happened? That's exactly what happened. And I bet you that you bought an out-of-the-money option when you did that. You see, out-of-the-money options consist only of extrinsic value. Extrinsic value is susceptible to, obviously, theta, time decay, but extrinsic value is very susceptible to decreases and increases in volatility. Vega. Now, Vega is not volatility. Vega is an option's sensitivity to volatility changes. So Vega, like theta, is given in cents. Vega stands for the change in options price per a 1-tick movement in volatility. What do we mean by 1 tick? 1 tick means implied volatility going from 34 to 35, from 87 to 88, from 1,257 to 1,258. 1 tick. When the volatility changes 1 tick, your option is either going to gain or lose. And the amount it's going to gain or lose is told to us by Vega. When we're positive Vega, that means we probably purchased options. We benefit from rises in volatility, and we get hurt from decreases in volatility. When we're short an option, we're going to be short Vega. We benefit from decreases in volatility, but we get hurt from increases in volatility. Now, when we look at Vega, we have to understand how it actually works. We have to understand that when I'm long an option, I am long Vega. When the stock trades up, my option increases in price. How much? By the amount of Vega. If I'm long an option that's worth $2 and my Vega is 5 cents, I am going to see an increase in volatility taking my option from $2 to $2.05. However, a decrease in volatility with that same option while I'm long Vega is going to take my option price from $2 down to $1.95. If I was short the same option and volatility went up, being short the option, I'm short Vega. If the volatility goes up one tick, that $2 option will now be worth $2.05. It will have increased in price. But I will be a net loser of that 5 cents because I sold an option which is now more expensive because volatility increased. But if volatility decreased one tick and I was short that option, short Vega, I would see that option go from $2 down to $1.95. I would now benefit, make money, because the option that I sold it to is now only worth $1.95. That's how Vega works. We need to definitely see how much Vega affects different options. Now, we do know that Vega is one of the strike-based Greeks. And because it's a strike-based Greek, it is going to have something in common with gamma and theta. We said that gamma and theta were biggest where? At the money. So is Vega. In any different month, when we look vertically, we see that the biggest Vega is right at the money. And it decreases as we move out of the money in either direction. And it's true for every month. Every month. But there's one slight difference with Vega compared to gamma and theta. See, gamma and theta, like Vega, all three of them are biggest at the money. But gamma and theta decreased as we went out over time. Vega doesn't. Vega does the opposite. It's the only difference between the actual nature and behavior of these strike-based Greeks. Vega actually increases in the out months. The reason for that is volatility, which Vega measures the sensitivity of an option's price to changes in volatility. Volatility is a product of time. The more time, the more volatility. Remember, volatility is an annualized number. Think about range when we talked about that. We said that a stock that's $100 and a 30 volatility will have a $30 up range and down range, right? The high would be 30% of 100 plus. The low would be 30% of 100 minus. We'd have a range of 130 on the high, 70 on the low. We also said that being that that's an annualized number, if we cut the time in half, we would cut the range in half. For 6 months under a 30 volatility, we would see a range not from 70 to 130, but 85 to 115. And as the time decreased and we got closer to expiration, that range would constantly tighten. That means the more time that's there, the more effect volatility has. And if that's true, then these options will have more of a sensitivity to movements in volatility from a dollar standpoint in the out months. Because when I increase the vol in the out months, the range gets dramatically bigger. If I increase the vol in the front months, the range will get bigger, but not dramatically, because it's an annualized number. These months will see, June, that front month, will see 1/12 of the increase of range that January would see. Thus, the options out here have to be that much more sensitive to movements in volatility. Their price will fluctuate more with the same one-tick movement in volatility. Here, we have an option that will change 5 cents. If I own the June 65 calls, I'm an owner, I'm a buyer, I own it. That makes me long Vega. If I'm long Vega and these June 65 calls that are trading for $2 went up 1 tick in volatility, my option will increase 5 cents. My option will go from $2 to $2.05. But if I owned the January 65s, 20.5 cents of Vega. When the volatility goes up 1 tick, my option will increase in price 20.5 cents. I go from a $2 option, 1 tick of volatility increase in January, my option's now worth $2.20. On the other side, if it decreased 1 tick, my option goes from $2 down to $1.80. Volatility is much more of an effect in the out months than the front months. And since Vega is measuring the effect of volatility on my options price, it's obviously going to be much more sensitive in the out months than it is in the front months. Keep that in mind. It's the only difference between these risk-based Greeks in terms of their behavior and their appearance. They're all biggest at the money. Gamma and theta, front month at the money, biggest. Vega is also biggest at the money, but out month at the money. Keep that in mind when you're buying out month options. A lot of people like to buy leaps, or they like to buy a 9-month option because they have a longer time frame horizon in mind. That's fine that you move out this far, but understand, by moving out this far, you've increased your exposure to volatility movement. So you might be thinking, hey, this stock's going to go up for a very long time. It might. But do understand that as it goes up, if you own the option and you're long volatility, volatility decreasing is going to have a much bigger effect out here in an out month than it will in a front month. We've got some important second-tier Greeks. Now, these second-tier Greeks are not something that you're going to see every day. But remember, your Greeks are measuring risk for you. We know that as the stock price changes, our risks change. We know that as the stock price changes, our price changes, delta changes, gamma changes, and vega changes. Second-tier Greeks measure the changes on the first-tier Greeks from changes in certain variables. First one, it's called V-delta. Short in the business, V-del. What does it do? It tells us how volatility changes affect delta. That sounds familiar, doesn't it? We must have done something a little while ago that sounds a lot like this. Volatility affecting delta. That was Trumpification, wasn't it? Trumpification is measured right here, V-del. How much are delta changes with a movement in volatility? We already have a general idea on that, don't we? We already know that as vol increases, in the money option deltas decrease. Out of the money option deltas increase. T-del, time, theta effect on delta. That's Trumpification too, right? Because we said that time and volatility walk hand in hand. Their effect on delta is known as Trumpification. So now, not only do we know that these options will crunch, we know how much that crunch it will be. And we know it down to the exact delta. Every day goes by. How will delta be affected by this time decay? V gamma. Guess what? Volatility affects gamma. And in a way that you couldn't imagine. Most people think that, wow, volatility should make gamma grow. It doesn't. You see, the higher the volatility, the lower the gamma. Why is that? Because when we look at higher volatility situations, deltas crunch, don't they? They become a lot closer. Movement in the stock doesn't now affect the deltas as much because they're all crunched together. All these different options are all the same delta. We saw that crunch, Trumpification. What happens is because volatility is so high, the stock moves, the deltas don't move much. And if the delta's not moving, what happens to gamma? It decreases. Increases in volatility decrease our gamma. Well, hey, if volatility's doing that, what else is doing that? Time. Remember, the further out months have more of that Trumpification, that delta crunch. So what do we know? The further out we go, the less effect gamma has. So when we look out over time, with more time, gammas get smaller. We saw that in the gamma chart. Smaller gammas in the out months. Why? Because a movement in the stock doesn't affect an option's chance when the option is 9 months out. When it affects the option's chances when it's only a couple weeks out. And finally, V theta. When theta moves, it moves an option's price by changing the extrinsic value. If that happens, then the extrinsic value is the part that gets affected by decay. More extrinsic value, more decay. More decay, higher theta. So when vol goes up and puts more extrinsic value in the option, theta thus becomes bigger. When vol goes down and theta is sucked out, why? Because the extrinsic value is sucked out. Smaller theta. Having an idea of these gives us a real good idea on risk management. I know where my risk is. Now, what could affect my risk? It's kind of like a chess player, a great chess master. They say that a great chess master plays 5 steps, 8 moves ahead. Does he have a crystal ball? No. He just knows every potential move you could make. That's what these second-tier Greeks do. They tell us every potential move, every potential risk that could happen before it does. And once we know that, we can be prepared for that. This is what risk management is really about.
All right, Ron, well, that was a great explanation. I'm glad that you have a gift that you can break these things down so clearly for people to understand, because understanding the Greeks is really the key to understanding how and why options are priced the way that they are. The next thing that you're going to cover is synthetics. And when you understand synthetics, that really trains your mind to understand why an option is going to be priced a certain way, why a call might be priced relative to the corresponding put. So before you go and cover synthetics, before you pop in the next DVD, optionsgps.com, hang out in the community and ask some questions, maybe answer a question or two, and then take the quiz, pass the quiz, and then I'll see you on the next DVD, which is synthetics.